In software engineering, we are taking chapter number 33, Estimation for Software Projects. So before we go ahead, whether it is a software project or any kind of project means a work which is quite substantial, big. Even movies, they are called movie project. Okay. So whenever we are talking about software project, we need certain estimation. We will use the word estimation, not the computation or actual, because not mathematical formula precise are used. These are all based on certain experience, or empirically things are calculated or computed here. So we'll talk about estimation. So software project management begins with the first thing which is called as project planning. That is, if you want to go from one place to another, then you need to plan. That is how to reach from A to B. So before even the project can begin, the software team and the managers should estimate, because the family is going, for example, one place to another. What needs to be done? In software term, what work need to be done? What are the resources required? How much, when, what time, the amount of resources, and from A to B, what time it will, the span will be there, so time to finish. So after this, software team should do what? Then they have to establish a project schedule. That is, okay, we'll start at 6 o'clock, reach this place at 6 evening, then we'll stay there, we'll have dinner there, we'll again start. At what time we reach, in between we'll be there for some tea. So same way, we have to define the software engineering task and the milestones, what time where we have to reach. And then we have to do the project management and controlling and tracking mechanisms also. And then we have to identify, because when we have identified the task, that is, which work has to be done by whom. In the whole software process model, we do requirement, then design, then we do coding, then we test, and finally we deploy. So all these work are to be done by whom, when, what is the responsibility, and what is the inter-task dependency. Because the coding can only start when the design is completed or in between. The testing will be based on previous two phases or the requirement also. So there will be an inter-task dependencies always. That has to be specified. Now, McGraw-Hill says a very interesting thing, that most of the team, they don't give much time in planning. Because if you want to go from one location to another, if you spend a little bit of time in planning, then if some problem is there, some contingency is there, or say somewhere you are stuck, then you don't need to spend your time on reworking. So most of the time, the team, they waste the time, the last moment, in replanning, rather than just giving 7, 10 or say 15 days in proper project planning. Estimation, different models we are going to see, Kokomo, Putnam, and statistical. This is all project management system I wanted to highlight. Observation on estimation. Now, whenever we plan, as a planner, we need certain initial commitment. It may be working, it may work, it may prove wrong. Because the estimates, all these software estimates which we are going to see, they look into future. And they will accept some degree of uncertainty. There will be some, degree of that, whether it will happen or not, or something can go wrong. All these things will be there. So the estimation of what we are doing, what are the resources, the software, hardware, people, the cost, of course, very important. Everything happens for money. And schedule. If 1 year task is given, you have to complete it in 11 months. This is what we should plan. So all this software engineering effort requires experience. That is, this idea we get from experience. There may be people who are senior, they can give you idea how much, what is when required. And there are certain historical information or the metrics already there, so you can employ it, that depending upon the project, whether it is complex, whether it is moderate. And there should be a courage to give predictions quantitatively. That is the numbers. Okay, this many person months, this time. So, if you say that 3 months will be taken for the feasibility study scope and the requirement specification, then there has to be a number. 3 months has to be in the number given. It may be possible only qualitative information exists, but you need to have courage to give the quantitative predictions. An estimation carries inherent risk. There will always be risks that will lead to uncertainty. Okay, sometimes lockdown will happen, sometimes some person will leave. This may happen. So you have to think about that. So the project complexity, and one more thing is there, which is the project size. There are uncertainty, it will be risk, there will be risk, but that has to be known upfront. As I said, the project can be different type of project, different specialized software can be there which you are making. You will be making web app, you will be making the mobile app. So all these, their project complexity and project size. Project complexity has a very strong effect on the uncertainty which is inherent, embedded in planning. And the project size is an important factor because that is going to affect the accuracy, the precision, the efficacy of the estimate. So whenever we talk about uncertainty and the risk, Murphy's law always is there, and Murphy's law says what can go wrong, it will go wrong. And the degree of structural uncertainty also has an effect on estimation risk. That is, what you are making, you have to make that, what are the structure being formed, and you have to stick to that structure. But sometimes whatever you have made may be uncertain. The project planning process. So software project planning or any project planning, what do you do? The objective or the goal is the manager should have or should give or should make reasonable estimates for the resources, hardware, software, people, cost, and the schedule, the time to complete the software engineering work. It may be, estimate can be best case, but we need to see the worst case scenarios as well, so that the project outcomes can be bounded. You cannot leave it open-ended. That is why best case and worst case, minimum maximum has to be chosen. Okay, this is the best case, this is the worst case. So for the project planning, what is the task set? What actually you do in project planning? We start with establishing the project scope. Scope is all about what you intend to do, what the functionality will be there, and then we'll do the other things like boundary, constraints, then the feasibility, whether it is possible or not, and then we'll do the risk analysis. We have to analyze the risk because project planning is all about contingency, analyzing the risk, uncertainty, and then mitigating it. Then we have to define required resources, like we have to determine the required human resources, reusable software resources like the component, and the environmental resources, because the environment has to be there for software engineering tasks to complete. Then we'll estimate the cost and the effort, how much money, how much effort has to be put in. So for that we have to, if the problem is big, we can just decompose it. And then we will develop 2 or more estimates for these different decomposed parts using the size, the function points, the process task, and the use cases. and then we'll reconcile the estimates, because different estimates can give you different idea, so you have to come to an average. Then you have to develop a project schedule. That is, what is the task set, whether it is meaningful or not, what are the different tasks and how they are connected, that is how they are dependent or independent in the network. Then you have to use the scheduling tools. You can use the PERT, you can use the Gantt. Normally PERT is used, and then defining the schedule tracking mechanism, because only making the plan is not enough. You have to look for tracking also and control mechanism for project. Software scope and feasibility. Now, software scope is designing what, or describing what. What are you going to do? This is the boundary. This is the work we are going to provide. So the functions and features that are to be delivered when the software will be completed, that is what software scope will contain. The data, that will be the input, and what data will be the output. And also what actually user has to be given, the content that is presented to the user as a result of using the software. Then comes the performance, the constraints, interface, reliability. Now the scope of project can vary differently depending upon the size, the complexity, the cost. So here we are in scope, we are talking about performance. That this is, if this is acceptable, I'm giving this. Then the constraint, the boundaries, I will not go beyond this. This software will work only in this constraint. The interfaces, if different subsystems or other parts are involved, then how the interfacing will be done. And the reliability. Reliability also associates with the availability. So reliability, how much you can, trust this particular project output. The scope is defined using mainly the two techniques. So we have a narrative description of software scope, and this comes out when you have a proper communication with your stakeholders, end users. This is the first way. There is proper IEEE template. There is also different templates, so you can use that. And a set of the second thing is you can employ UML. That is, a set of use cases is developed by the end users. Please see here, end users. Both the cost and the schedule, whenever we are estimating it, they are functionally oriented, because the project can be complex, it can use multiple technologies, it can use various other things. So there has to be some degree of decomposition, that is, dividing the project into multiple major parts so that we can estimate. The performance consideration, that is the processing time of various functionality, the response time. So I'm just saying that we have database or communication technologies or any other part you are taking, or a very specific field project you are making. For that, they are functionally oriented, and along with this, the processing and the response time, this comes under the performance issue, which is most likely the usability aspect, because the user has to accept, because he is going to be working on it actually. So these are very important part of any kind of project planning or project thinking. And the constraints are also there. These are the limits, these are the boundary created or placed by the external hardware, the memory availability, the existing system, network bandwidth. There are so many things. So one scope has been identified, of course with the concurrence to the customer, because you have to involve your customer. You can ask them now, can we build software to meet this scope which we have decided? Is the project feasible the way we have thought of it or conceived it? So Putnam and Myers, they suggested that after the scope is properly understood, we have to determine if it can be accomplished or it can be done with available technology, dollar, time, resources. Because the technology may be different, the time you completed the technology may be different, Of course, the money, time, resources are the integral part. Resources. Now, resources can be variety of aspects we can think. Can you work without a computer or an environment, without people, without your store department, without your admin department, without your security? Can you work? There has to be environment also. On a church, you cannot play DJ. The environment is not like that, or it is not allowed. So the second planning task in estimation for the of the resources for software development effort is all about resources. So there are three major categories of software engineering resources. You see this resource pyramid, the top one is people, you, me, and the components. Components are basically those which can be easily used, reusable, and finally the development environment. You need work to work with an infrastructure, with hardware, with software. There are so many things which people and the other aspect require. So each resource is specified with 4 characteristics. First, what is the description of the resource? Even people, hardware, components. The statement of availability, when the component will be available, when we are going to hire people for this work, and time when the resources will be required, and for what time they are required, duration of time that the resources will be applied. For example, we need here for this much time. So this is a time window. So the last 2 characteristics which we just saw, this can be viewed as a time window. And availability of resource for this particular time window must be established as a planner or as a manager at the earliest practical time. This is required. Okay, before we go ahead, let me just show you what exactly these means to just revise. In a project, we need people, environment, reusable software. People, how many people are there, what skill set they have, which location they are placed, environment, hardware, software, and the other resources, and then the reusable software like the codes, components. We'll just talk about that. So now here the planner will begin by evaluating software scope, and depending upon the scope, how many people with what kind of skills we require. How many people will be done only after effort estimation. So both the organizational position, it can be manager, it can be senior software engineer, and we need this specialist also. For example, some telecommunication people, the database, client server, FPGA or GIS person, we always need them for different kind of activity, specialized activity. Because software are made for a certain field, for some certain stakeholder. If you have a small project, it can be done by one person in few person months. Single individual can do, we are not talking about that right now. For moderate to large product, the software team may be geographically dispersed, one in LA, one in Nigeria, one in India. So the location of each human resource has to be specified. And people required can only be found or determined only after we estimate the development effort. For example, the person month. Person month means one person in 1 month, how much work he does. See, in the kilogram for weight, the meter for distance, length, that is the same way effort, the unit is person month. For the effort, the unit is person month. Reusable software components or reusable software resources. Now we are talking about, say, e-commerce website you are making. There is a payment gateway, there will be a calendar. So there are so many part of that particular software or the app. You don't need to reinvent the wheel. So component-based software engineering, it emphasizes the reusability. That is, there are software building blocks. You can create and they can reuse it again and again. If the technology is stable and you already tested it, so these components must be, first of all, cataloged, because you need to use it. So for easy reference, then for easy application or applying it in your software project, there has to be some standardization. And of course, the validation, because you are going to integrate it. It has to be properly validated and verified and tested. So Bannerton suggests 4 software resource categories to be considered as the planning will proceed. I'm talking about the reusable software, the resources components. First is the off-the-shelf component. That is, you can just go to the third party, you can just buy it. Or if you have past project which is already there, all having all these properties which we just discussed, just you can use it. Then you can have the full experience components. We also call it the off-the-shelf as COTS component, off the shelf. Full experience component. If you have specification, design, code, and similar test data, you already have it existing, which is done already. You can just use it directly. Full experience component. If the project was successful, it is working, so you can directly use it rather than reinventing the wheel. Partial experience component means you already have certain specification, design, code, similar data, but you need certain modification changes until you can use it. And the new components are the components you have to make it from the scratch, or it is specifically for the need of the current project. So these are the 4 components, reusable software resources. Then comes the environmental resources. As I said, a DJ or disco has an environment. You will dance there. You will not pray there. So for making a software, you need an environment. You need certain inputs. You need certain support system. So the environment that support a software project, called as the software engineering environment, it incorporates the hardware and the software. You need the different support system. As I said, for a company, software company, you need administration and store department also. So hardware, software, tools. So hardware support tools, that is the software required to produce the work. Without software, hardware, how are you going to work? Okay, this is important. And we need to prescribe the time window also, whenever this hardware and software is required and when we are going to get it, whenever they are available, because until you get the proper support, how are you going to make the software project complete? Software team may require access to elements, because if some team is making something and you need it for your validation or for your, say, integration, then you have to wait for it. For example, here you see software for a robotic device may require a specific robot. For example, you see here a robotic welder as a part of the validation test step. So there is an interdependency. For that, resources, environmental resources, just say that you need an environment so that you can work properly. You don't need to wait endlessly, and you need to get support from the management. Software project estimation. We are not talking about computation or any mathematical formula that is already been established. We are talking about estimation. So in order to achieve reliable cost and effort estimate, there are certain options for these software projects. First thing we can do is we can wait until the project is finished or complete, and then we can estimate. The second thing is similar projects which have already completed successfully. We can base our estimates on those projects. This project, last project, this much cost, this project, this much cost, like that. And we can use simple decomposition techniques for estimating the project cost and effort. Decomposition is all about thinking the project as a big part and dividing the sub part, and then finding out the cost and effort for all of them and combining them. Or we can use the empirical models for software cost and effort estimation, that is already established certain, say, formula or expression that has come from previous past, you can say, experience or results. The first is not practical. Why? Until the project is complete, after project is complete, then you decide to estimate. There is no point. Second option, because most of the time the past experience will not give you that kind of indication or good result that you can apply and tell for the present project? Most of the time it happens. I'm not saying it always, but we cannot rely always upon the similar project to give us the cost and estimate. So we will use the simple decomposition technique kind of way, or the empirical models. So decomposition is all about dividing and conquering. That is, we assume the project as to be, say, a idea or a form of problem solving. So it's a big problem and we are solving it. So too complex, we cannot consider it. So we have to divide it into different pieces. That is, we will divide or decompose a project into major functions, sub-functions, all the related software engineering activities, and then we will try to estimate, and then finally we'll do it in a stepwise manner. The empirical estimation, the fourth point, is actually helping, complementing the decomposition techniques. A model is based on experience, historical data. So what all model we can find out is a simple function. That is, one thing is function of another thing. That is, we are saying the cost or the effort or the time. This is the function of what? This is the function. For example, this D. D is a variable. This is dependent on V, the function of V. So the cost, the effort, the project duration, all these is dependent on which factor. Just assume y equals fx. So y here is all these three, and this x is nothing but the LOC or FP. That is, we can select the independent parameter. That is, you can give process, you can give the use case or the line of codes or the function point. So we'll talk about all these, mainly the LOCs and FPs. So we have decomposition techniques. First we do the sizing, and then we do estimation. We can use use cases, and finally the problem based estimation, as you just found out, D equal FVI, is based on LOC or FP and other parameters also. So there are cost estimation models like the empirical estimation technique, heuristic technique, and the analytical estimation techniques. These are the basic cost estimation models. I will see all of them, whichever is possible in this discussion. So project estimation is a problem solving, and then we assume it to be too complex. We decompose the problem, because why I'm telling you again and again, because until you divide it properly in terms of a line of code, in terms of function point, the project planner has to understand that when the scope is decided, the next part is sizing, and sizing comes from line of code and function points only. So the decomposition is the basic parameter here. Software sizing. Now, first thing is, in order to give estimate for any project, I'm not talking only about a software project. Any project, what is the size, what will be the size, and if you want to accurately measure it or estimate it. So software project estimate depends on the accuracy of all these, depends on what you have done. That is the degree to which you have properly estimated the size of the product to be built. If you know in advance that this much broad or this much wide software I am going to make, these are the line of code, or you can divide it into functionality. So if you know that line of codes, this will be there, this will be the function, then you will be saying that, oh, I can estimate. The second thing is, once you have found out the line of code and function points and the use cases or the processes, then you may be able to translate all these into actual estimation parameters or estimated parameters. That is, once you get the size, you can tell what will be the effort required, human effort required, person month required, the calendar time, the time required to complete, and of course the dollars, the money. Then if the project planning is done so that it knows and it attributes the responsibilities and abilities of software team. That is, if you talk about the giants like Infosys and the Wipros and the Accentures, they have good team. They hire good people, and they follow a proper software engineering work environment. That is why the abilities are used. And finally, whether the requirements and the environment is stable, because until you understand the requirement, there is no point in going ahead. And wherever you work or wherever the project is being made, the software engineering environment and all the other environment like the infrastructure, etc., has to be stable. So software sizing, as I said, can be function point, it can be line of code. In project planning, the size is a quantifiable outcome. If you know the size, if you can estimate the size, you can find out the size, or you can anticipate the size from, any way, empirically, heuristically, anyway, the size is a quantifiable outcome. Okay. So the direct approach for software sizing is simple. You know how many line of codes you have written or going to write. The size of can be line of code. Just count the number of instruction. We also call it as the DSI, delivered instruction, software instruction. So this is how direct approach can be done. Or otherwise, you can use the indirect approach. That is the function points. That is function. How many functions this code or this software is going to give? Function points. So this is the software sizing. Either line of code or the function points you can apply and you can use. Okay. Function point we have already seen in the earlier chapters. How to find it out. Putnam and Myers, they suggested 4 different approach for the sizing problem. What were there? Fuzzy logic sizing, then FP sizing, function point sizing, standard component sizing, the change sizing. These are software sizing, and size can be estimated by various parameters aspect to be kept under consideration. First of all, what is the type of project? In which application domain you are going to work? Either it is a real-time system or an embedded system or a wireless application or for say mobile application. And what are the functionality delivered? The functionality delivered is nothing but the function points. These are the basic function points. Functionality delivered. So it may happen that in some software there will be multiple functionality. There may be some less functionality in some of the project. And then the number of components to be delivered. See, the function point and functions are operation and say methods and function. Components are the combined, you can say it is a module kind of thing. So you combine various functions to make a component. So component can be delivered. For example, I'll just give you an example. This is an e-commerce website and you are making it, and mainly people will buy and you use the payment gateway. When they will use a payment gateway, that particular component is already made. You don't have to reinvent the wheel, so that components can be delivered, can be bought. The degree to which a set of existing component must be modified for the new system. Now you already have a system or a component already there, and then you can reuse it with some certain modification. So these are the size can be estimated by considering all these factors. Now Putnam and Myers, they also suggest the result of these sizing approach that can be combined statistically. You can create a 3-point or an expected value. 3-point is, I'll give you an example of both of them. Just assume there are 3 people. 3 people. And for the same size, same value or same aspect, one person is very optimistic. He's very optimistic. He says everything will go right. The pessimistic will say nothing will go right. And then most likely, he will say, he's logical. He'll say, okay, this can happen, this will not happen. He's logical. So that is what we are saying, that first one is optimistic, the middle one is most likely, and the third one is pessimistic. First one will have the lowest value, last one will have the highest value, and most likely will be having middle value. So this expression is actually a PERT PERT expression, but I'll tell you from where it has come. Because mainly we are talking about 3 point, but we will not be using it. We will be using this expected value estimate. See, say this, the optimism was say S optimism, the pessimistic is say SPESS. I've changed the people, okay? So don't worry about that. And the middle one, of course, we have to worry about. So we said S sub M. We combine them, divide by 3. This is called the 3 point. This is used, but in our here in our computation, we will use the PERT. Same thing, 3 point and expected value, but only we will give certain weight. We will multiply the middle one with 4, and the division is with divisor is 6. So the first one is optimistic, second one is most likely, third one is pessimistic. And this is the size we are going to accept. In any project, the sizing approach, estimation can be done using this. Problem-based estimation. For any software project, we have to, because any estimation, anything can be done only when you are clear about the project, what we actually want to do, what we are going to solve, what is the problem in front of us. So this LOC and FP data are used in 2 ways during the software project estimation. Line of code and the function points. First is an estimation variables to size each element of the software. That is how many line of codes, how many function points. And then the baseline matrix collected from the earlier projects or the past projects, and these are used in conjunction with the estimated or estimation variables to develop cost and effort projection for the present project. For example, past project, okay, 50 functionalities were there, this was the amount, 2 lakh was the amount. So now you can project it. Okay, this time it will be 2.5 lakhs. The functionalities will be around 52. This way you can estimate. This may change, but everything will start with scope. You just know that all these things will come from scope of the project. See, the LOC and FP, they are this kind of estimation. They have some certain things in distinction, but they have some common characteristics also. But as I said, everything will start only by the software scope. So when you have a project, then you will define the scope of the project, and those statements which are written in the scope, they will be bounded. We need to bound it. We cannot have an open-ended question. For example, I will go tomorrow to meet that guy. Now, which one is that guy? You have to bound it. So you have to tell properly which guy, name of that guy. And then we will decompose this statement into individually estimated problem functions. And for each of these functions, LOC and FP can be estimated. That is, from this scope, one statement will be taken. From that, we will take out certain functions or the line of codes. We will estimate from each of these. So this scope will finally be converted into function points and the line of codes. I'm not just saying that line of code and FP are the only way. You can also use for sizing classes, object, changes, the business processes. These are always there. We'll talk about these. Basically, we'll talk about the LOC and FP, but other also sizing factors. We are going to see how to compute them, estimate the project variables using these also. Okay. First, scope is important. And the baseline productivity matrix, for example, the line of code per person month and the function point per person month, these are applied to the appropriate estimation variable now. And then we will derive the cost and effort for the function, for the value. That is, function estimates are combined because one function, second function, third function will combine all these to find an overall estimate for the entire project. For example, 50 FPs are there. We'll do it all for these 50, then they will combine. And this LOC and FP, when we take the average, it should be computed by project domain, in the project domain. So the project should be grouped by the team size, about the application area where it works, and the complexity, project complexity. It is easy, it is complex. And then the local domain averages should then be computed. Because every project and every computation has to have some local limitation and boundaries also. Okay. For example, in India, there is so much religion that things are, guided by religion, nothing else. So LOC and FP differ in the level of detail required for decomposition and target of partitioning. You'll see in the example when we'll do. LOC, decomposition is quite essential, and you have to go to a considerable levels of detail in order to find out the LOC. And this in FP, what do we do? We have already seen the FP function point analysis in detail. So we have certain parameters, actually 5 parameters: inputs, outputs, inquiries, files, and interfaces. All these, how many numbers are there, we'll take. There is already a matrix, a weighting factor matrix, weighing factor matrix, and then we will put the counts here, number of input, output, inquiries, files, and interfaces, multiply with the column, even if you take simple or average or complex, and then we multiply them, and then we find the final count. This count, then we have the 14 complexity adjustment value factors, and this we will give from 0 to 5 value, and we'll just add all these 14 parameters, and there is a formula. We'll use this formula to compute the final value of a function point. See, using the historical data, intuition, then we'll use the optimistic, most likely, and pessimistic size value for each function, or count for each information domain value. And this 3-point value, or 3-point or expected value I'm talking about. Then the expected value for this estimation variable, that is the size. These are computed as a weighted average of what the formula you see here. As I already explained you, middle one will be multiplied by 4, others will be like that, and we add them and divide by 6, because we are giving heaviest credit or credits to the most likely estimates. So we just assume that optimism and pessimism are minimum maximum. Mostly the middle value will have more weightage. So after the expected value for the estimation variable have been determined, this historical LOC and FP productivity data are then applied. So this is an example of LOC based estimation. We have already known about the steps. We'll apply it here. First of all, we have to write the project scope. In the scope, we'll write different narrative or statements. And with these statements, we will try to find out how many functions will be made. And consequently, the line of codes we have to write. So start with the scope, then we do the sizing, function point and LOC. And then we have various expression. We'll put the expression in this FP and LOC values in that, and try to find out the effort, cost, and time duration. So this is how the steps will be taken. The example we are taking is, there is a software package. This is to be developed for a CAD or computer aided design application for the mechanical components. Okay. The software has to execute on a desktop workstation, and it has to interface with various computer graphic peripherals like the mouse, like the digitizer. It will have a high resolution color display, laser printer, and even the plotter, and there are various others. So first thing first, for any estimation is the project scope. Now just ask from the user what do you want and write the scope. Now you are writing the scope. It is first draft, so it is not bounded. For example, not bounded means I will go that day to this one and do that thing. So these are kind of unbounded sentences or narrations. you have to fix it and you will make it bounding. So let me tell you again, this is the project. For that, what we have to do, we have to write a scope. Now this is the preliminary draft scope. It is unbounded now. The mechanical CAD software will accept 2 or 3D, three-dimensional geometric data from a designer. So input will be this one. The designer will interact and control the CAD system through a user interface that will exhibit characteristics of good human-machine interface design. So user interface and control facilities we are talking about. And all geometric data and other supporting information will be maintained in a CAD database. So we are talking about a database management. Design analysis modules will be developed to produce the required output, which will be displayed in various devices. And then we have the software. This will be designed to control and interact with peripheral devices that include mouse, scanner, laser, printer and plotter. So here we have to have a peripheral control function, and in between we see the design analysis module also. Now every sentence what is written here in the project scope need to provide a concrete detail and quantitative bounding. So we have to bound it with certain quantitative analysis and then see how many functions we can find out. That is, every sentence have to be bounded. It has to provide proper detail. For example, let us take the example of good characteristics of good human-machine interface design. What does it mean? We have to bound it. Or what will be the size and sophistication of this CAD database? So we have to think about database management also. We have computer graphics display facilities. We have 3D geometric analysis. We have 2D geometric analysis. These are all the functions that will come out from here. Okay. Now let us assume that this scope, all the sentences have been bounded. We have all these. We have refined them. We have finally found what are the functions we need to ponder upon, deliberate upon, and then we'll make these functions. And these functions will be the basis of the sizing. Scope have already been done. And then refinement to sizing. So after further refinement, major software functions are identified. So for this, let us see here. These are the major functions. If you read that scope again for the problem, user interface and control facilities, it is clearly given in there in the scope. So UICF you can call it. So there will be some estimated line of code, and this has come from where? From various decomposition technique and historical data. For example, we have made this function. For example, database management. We are saying 3350 lines of code has to be written. These are estimated line of code. So following the decomposition technique, we found out these functions, estimation table we have developed, and there will be a range of line of code which are estimated to develop the each function. That this function will take this line, this function will take this line. And this function has come from project scope, which we have bounded, refined and thought of with respect to the function. For example, now come to our specific, say 3D, three-dimensional geometric analysis, 3DGA. This is the function. Now there are three different ideas we have come. For example, three people are there and they are just saying that the optimistic is saying, no, only 4600 line of code will work. The pessimistic is saying 8600 LOC line of code you have to write. The middle one, the most likely will be 6900 line of codes. So these, for one function, we have to have three multiple inputs from various historical data, various inputs, where various experience, everything. So someone is saying, okay, 8600 line you have to write. The optimistic is saying 4600 line of code. The most likely is saying 6900 line of code. Okay. So now what to do? We will use the 3-point or the expected value estimation statistical result. How to use that? We will use this 4600. We will add it and then multiply 4 with 6900, the most likely. Then add 8600 with this one and we will divide it with 6. This is the final value. So we will use 6800 value, which you see in that table also. This is the estimated line of code. And this you will do for each and every function that is listed in this table. Okay. I hope you got the idea. Scope, then sizing. Then sizing in these three different thoughts and then combine. So by summing all these vertically, all this LOC column, when we add this, the total line of code which we are estimating is 33,200. So 33,200 lines of code we have to write. Okay. Now we are arrived at this. And when we review the historical data, that organizational average productivity of this type of system, of CAD system, computer aided design system, we found that the result is 620 LOC per month. So in a month, a person month, PM is person month, that in a person month, one guy in 1 month will write 620 codes. Let us say that. So let us say that the labor cost or the burden labor rate is 8,000 per month, $8,000. This is the cost. So what will be the cost per line of code? See, you have already the given values, 33,200 lines of code you have estimated. You know by past 620 LOC per month, 8,000 is the dollar. So what you have to do is just divide this amount 8,000 with this 620. So what will be the cost of one line? So 12.9 or $13 is the cost per line of code. The cost per line of code is $13. 8,000 divided by 620, which is LOC per month, got from historical data. Now you see this LOC estimate and the historical productivity data. What will be the total estimated project cost? How do you know? How do you compute this? You know, one line of code is costing $13. There are 33,200 lines. The total cost will be 431,000, or you can say $431,000. And what about the person month? How do you compute it? So this is the cost. Okay, this is in dollars. So when you have to compute the person month, the effort is always computed in person month. This is the unit of effort. Person month is one person, how much work he does in 1 month. So these are number of line of codes 33200, and you just divide it with this 620 LOC per month. So all the computation which I have done is just by using the units. I know which unit will come where. Then only you can easily find out. So this 33200 divided by 620 is going to be 53.5. Let us take it as 54 person months. So this is how we estimate on the basis of LOC. Now function point based estimation. For that, first you have to know about the function point analysis that we have already discussed. You can just revisit previous chapters and get an idea of that. But I'll give you an idea here also. First, there are 5 information domain value or input parameters. For a computer, the problem is there is a computer aided design software we have to develop, and this software package which is to be developed for computer aided design application for mechanical components. So first we write the scope, all the statements, we bound it and we refine it and try to take out the functions which we have to make. So certain functions we have taken out from the project scope. So these functions we have decided. These are the functions I am talking about. That is, you have to make a user interface, 2D geometric analysis, 3D geometric analysis, database management you have to do. You have to do the computer graphics display facilities, peripheral control functions, design analysis modules. For us CAD software, you have to do all these functions. These are nothing but function points, because function points are what? Basically, you are trying to find out the functions. The decomposition of FP based estimation focuses on the information domain values, which are these 5 values. Okay. So external inputs, external outputs, external inquiries, internal logical files, external interface files. Now, if you see the table here, we already found out the optimistic, likely, and pessimistic value. And let me just put that these three, take these three values of one row. So first one is 20, add it with the fourth multiplication, or multiply it by 4, the middle one, most likely, plus 30 divided by 6. So you get 24. So this is the estimated count. Now you have to multiply it with the weight. The weight is already there. There is already a matrix of low, average, and high. These are metrics, and you can say we are taking the middle one. So low, average, complex. You can take any one of these. I am taking, say, average. So now multiply this fourth column with fifth column and write it on the last column. And the finally multiplied value, you just add them. You get 320. So this is your function points. Now these function points 320, because there is a formula for function points. These are not function point right now. These are just count. But the basic function count, there is a way we have to add the value adjustment factor also. So this is just a count total. This is not function point. So this is just count total. Function point has a proper formula, because the adjustment factor have to be computed by these. There are 14 values, and we gave value each of them from 0 to 5. Any value depending upon the weight of these factors in your project. So the final formula is this one: count total into 0.65 plus 0.01 into sigma fi. Sigma fi is nothing but 1.17. Okay, and then we have this count total, which is going to be 320. Multiply here, add, you get 375. Now we got the function point. The function point already we have seen, so you can just revisit. But right now the 375 is our function points. Now the organizational average productivity for system of this type in different organization, the average value is 6.5 function point per person month. This we have got historically or from other organization, from other studies, you can say. Now the labor cost is 8,000 per month, burden labor rate. So the cost per FP, cost per function point is what? See, 8,000 is the dollars, and divide by 6.5. What do you get? 1230. So the cost per FP function point is around 1230, 1230. Now we have already known the FP estimated. So total estimated project cost will be what? This is 375, and just multiply it with your 1230. So you will get 461,000. So 461,000. This will be the cost, total estimated project cost. How to get the person month? For that, you already know this is 375, and just divide it with the 6.5. Already given that. So you get 58. It will be actually 57.69, and assume it to be 58. 58% month will be the value. So this is an example of FP based estimation. Process based estimation. Now whenever we make a software, a project, we follow certain software development life cycle. So these consist of certain processes that in turn consist of activities, and these are divided into tasks. So this is how we complete a project, different decomposition part, and that is how we can estimate also. So what will be the effort? What will be the time to complete? What will be the cost? So the most common technique for estimating a project is to use the process as a base. Like we were using the function points, like we were using the line of codes, we can use the process. So in a normal SDLC, we start with the requirement analysis, requirement engineering. Before that, we do the planning, also risk analysis. And after this requirement engineering, then we do the design. Sometimes the requirement engineering and design are combined. Then the construction part and the deployment part. So we'll divide these into different parts so that we can divide the activities, action, task, and then we can find out the effort, which is we can estimate it. So process-based estimation begins with the delineation of software functions, because the function will come out from where? From the project scope. So first of all, you have to write the scope. Then from there, you need to find out the functions. From these functions, the process will be estimated or to be found out. There are certain framework activity that has to be performed for each function. Then we estimate the effort, and effort is always computed in person month. This is the unit also for each software process activity, for each software function. There can be some average labor rates, for example, the cost per unit effort. These are then applied to the effort estimated for each process activity. Okay, I'll give an example also. How do we do this? So these are the boxes. You will understand what I'm trying to suggest. So we are taking an example of process-based estimation. So what will be the effort required? What will be the cost? And how much time the project will take to complete? So in order to get all these, we will take the base as process. We will be taking normally the function points, the line of codes, the use cases. Now here we are taking the process as the base. So the problem here is the software product will be a software package to be developed for computer-aided design application, and this is made for mechanical components. So we have written a scope properly. We have found out written that into a bound state. Then we refined it, and finally we came up with the function. So basically this is the sizing part. From scope we came to function. So I'm just saying that this particular problem, we have already defined the function. These are the functions which are already been defined. I assume that all things have been done. So from scope, size, and this size, the base is we are using process. So ultimately the main key is the functions. So these are the functions, broad and major functions that we need to implement. For example, 2D geometric analysis, 3D geometric analysis, database management will be a part, user interface, user interaction will be a part. Then there will be various peripheral devices like the plotter, printer, laser printer, and joystick, mouse, many of these. So we divided try to find out the main function so that we can divide the work. Now each software engineering activity estimate of effort in person month. For each of these software engineering activity, whether you are taking the waterfall model or the spiral model or any of them, they are provided for this CAD software function. You see here the engineering and the construction, these release activities we have subdivided. That is, from requirement we start, then we do the design, then we do the construction part, that is the coding part, and testing is also included here. And finally, we deploy the software or the application or the system. So the engineering and construction part, basically we are talking about a requirement engineering and construction part. So requirement engineering and the construction, we would like to divide it because we can divide these activity into different tasks. For example, engineering into analysis design and construction into code and test. So gross estimate of effort are provided for the customer communication, because before that we need customer communication, we need the planning also because we are doing the project management, and finally the risk analysis. There will be some problem that may come, the contingency plan, what will be analyzed and what mitigation activity have to be done. And now you see the total row at the bottom, it is giving you the values of what we have to put here, and the percentage effort also, how much percent it is required. Now the horizontal and vertical, you see this horizontal one, totals, and there is a total on the right vertical, and that is row and column, last row and the last third in the bottom part. So this is the activity, top one is the activity, and we have divided this activity engineering into tasks, for example, analysis and design. And in construction, we do the coding and the testing. So the activity or the framework activity, we have divided two of them into two parts: engineering, analysis and design, construction as code and test. So now these function, as I said, we have already found out. Now how much effort you are going to put for each function. For example, the first one, analysis part, requirement analysis part, 0.50. Then first one, the design part, 2.50. Similarly for construction release, these are the values being given, and depending upon the effort you are going to put. For example, in code, the maximum coding will be done in 3D GA and CGDF, that is three-dimensional geometric analysis, and the second one. So 3D GA, that is three-dimensional geometric analysis. Most of the time the testing will be done here only, 3D GA, so we put 3 here. Now this row, we are not giving anything to customer evaluation right now. So we are going to add this row, 0.5, 2.5, 0.40 and 5.0, we add them. Now these are the CC, that is the customer communication, planning and risk analysis. These we have given 11%, so 0.25, 0.25, 0.25. So row wise and column wise when we add, we'll get the same number, 46. Okay, so you see the total of every column, but the last column we add coming to 46. Similarly, the row with totals, we just add them and finally we get 46.00. So this is the effort only we are getting. Okay, so we are finally getting this number 46, which will be the base for other computation of the time and cost, etc. You see this engineering activity, requirement engineering activity, 45 and 8, 53% of the task is this only. So you got the idea? What are the rows and columns and how do we compute it? Okay. Now 53% of all effort is done or extended on front end engineering task. That is the requirement analysis and design part. 45% plus 8% is 53. So most of the work is done here. Now let us start the computation. Let us say that the labor rate is $8,000 per month. So the total cost which will be estimated will be what? See, 8,000 per month. How many number, what number we got there? 46. 46 is the person month because we are actually finding out the effort only. Now 46 just multiplied by 8,000. 46 is person month. So multiplied by 8,000. What do you get? And when you get this, I am multiplying it. It will be a number 368,000. This is the total estimated project cost. You also know the person month. You have computed the project cost. So effort and cost is known, right? And in this way also you can find out the time also, this span. So 46 into 8,000 is 368,000. Person month is 46. You can directly take from here. Okay. So this is the simplest example which I can give you for process-based estimation. Scope, sizing, and then this application. Estimation with use cases. Estimation is what? Finding out time, effort, and the cost. So here we have actors. This is a use case being made in UML, Unified Modeling Language. So an actor is someone who interacts with the system or the software. So a customer is an actor. Now he does certain activity like the open account function, deposit function, deposit fund, calculate bonus. So all these, the actor and these boxes or the round ovals, these are called transaction. It can extend, it can include. So these are called transactions. So use case, actor, and transaction. These are the three things which we try to find out from here. For understanding this, you need to know what is use case. So use case gives what? It gives us like a software team with insight into software scope and requirements. What is the software scope? What will be the requirements? So you can present it as a use case. Okay, as I said that UML in Unified Modeling Language, you can always present use cases. So now use cases This can be used for, as you were using the function points and LOCs, a line of codes and process, you can use this use case to project the size of the software project. Time, effort, money. There are certain challenges here while using the use cases as the base, because you and me, both of us will make the UML in different style, different formats. There is no set that everyone will make same way. And this use case is actually a user's view. It is from external. We are not going to interior. And because you can make say 10 transactions. I can make only 2 transactions. So the level of abstraction or the detail which you and me are giving for a same use case will be different. And this use case does not address the complexity of the functions and the feature that are described. It is just saying these are the function and feature. Who is going to interact in what way? And after that you will see the state diagram and the sequence diagram, the swim lane diagram, all these things will come. But this use case will describe complex behavior, that is the interactions. If you see here, transactions are involving many functions and features. So we have various constraints, but still we can use these use case points to find out the UCPs. You know the function point analysis, function points you used to find out. Similarly way, we can find out the use case points or UCPs analogous to the function points. So what we have to do here is, I'll tell you all the procedure, but Cohen, he indicates computation of use points must take certain characteristics into account. First, the use case, number and complexity of use case. So first you have to go for the use case, how many actors are there, so the number and complexity of the actors on the system. Then third thing is, you have to also consider the non-functional requirement, which are portability, performance, maintainability, like this, which are not written as use cases. There are environmental factors also for project development, programming language, software team motivation, that will also be included in the computation. So in order to begin, we have to know, if you start with use case, what is the complexity of use case? See here, a simple use case, it just indicates a simple user interface. So this is a simple use case. The complexity is simple. So simple use case may just be a user interface simple. It can be a single database. The number of transactions are less than 3 and 5 or less than 5 class implementation. So this is a simple complexity. If you say now my use case is average, so what do you say? A use case which is an average, it indicates a more complex user interface. It can have 2 to 3 database, unlike the previous one simple where only single database was there. And there can be the transaction between 4 to 7, the transaction I told you. When the use cases are formed, we show the transaction or activity. For 5 to 10 classes will be there. When you say my use case is complex, that means you can have a complex user interface, and besides that you have multiple databases, and there can be 8 or more transactions and 11 or more classes. So depending upon that, you will divide or you will categorize your use case into simple, average and complex. Now every use case complexity have a weight. For example, simple will have a weight of 5, average will have a weight of 10 and complex will have a weight of 15. So this is the way we find out UUCW. UUCW is simply unadjusted use case weight, and this is the sum of all weighted counts. For example, your project has 2 simple use cases, 2 average use cases and 1 complex use cases. I am taking an example. So you will multiply 5 and 2, you will get 10, 10 into 2 you will get 20, 15 into 1, 15, and you just add them. What do you get? 5 here, 4 here. So 45 will be the UUCW. Okay. Now I'll show you the expression, what all we have to find out, but first thing is UUCW. So this is the formula. UUCW is the first thing. We have to compute other factors also like UAW, TCF and other. Next part is we have to assess the actors. In a use case, how many actors are there? What type they are? What is the actor complexity? For example, if you categorize your actor as simple, these are simple. For example, a system which is defined working with API, another system, machine or device that communicate using application programming interface. If you say my actor is average, that is a system interacting through a protocol or a data store. Protocol can be TCP, IP or UDP like this. It is an average actor. Now if you say my actor has a complex complexity, that means a human or humans who communicate through this GUI or other human interface or user interacting through GUI. It can be a complex kind of actor complexity. Now we have already prescribed weight for each of them. Simple 1, average 2, complex 3. So for that we will find out finally the UAW, unadjusted actor weight. Now simple, for example, there are 2 actors, average 3 actors, complex 1 actor. So you multiply 1 and 2, you get 2, 3 into 2 6 and 3 into 1 3. So what do you get? 11. So this is the UAW or unadjusted actor weight. So as I told you, the expression 2 values we have found out. Apart from that, we also need TCF and ECF. TCF is simply technical complexity factor. These unadjusted 2 values which we just found out are modified considering this TCF, technical complexity factor, and the environmental complexity factor, which is the ECF. There are 13 factors that contribute to TCF, 8 factors contribute to ECF. I'll just show you what they are. But UUCW, you know how to find out. UAW, I just found out here. TCF and ECF are the 13 and 8 factors. We will give you the values and compute it. You'll just know how to compute this TCF and ECF. Then finally UCP will be found. So we have an example. In order to estimate using use case points. So the project or the problem, the software we have to make is a software package to be developed for computer-aided design application for mechanical components. So this software package, a scope has been written. The scope has been properly defined, refined, and finally from the scope we found out the functions. So this is the basic formula for the use case point computation. So all these 4 we are going to compute one by one. Before that, we need to know how many functions are there, major functions in this project. So as I said, we'll write the scope and then we will try to bound these sentences or narrations. Then we'll try to find out the functions from there and major function, and then we'll start our use case point computation. So let me tell you, or let us assume that these all CAD software functions we have found out, because in CAD we have to do 2-dimensional geometric analysis, 3-dimensional geometric analysis like this. For example, we have to do the peripheral control functions. So all these have been defined. Now this particular example, certain values are already given. I just say that this can be categorized. The example CAD software has 3 subsystem groups. First is user interface subsystem. It has UICF. Engineering subsystem group. It has this 2D GA, 3D GA, DAM, which is the design analysis module. Don't go into the detail, okay? I'm just giving you numbers right now. I'm just explaining how to get these numbers. And in infrastructure subsystem group, you have CGDF and PCF, that is computer graphic display facility, and you have peripheral control function. Now the numbers of all these I'm giving you, okay? So the computation starts from here. Just assume that we know the software, we know the values now, so we have defined the use case now. So 16 complex use cases describe the user interface subsystem, the first one. These are 16 complex, okay? So the first one, I am talking about this box. So complex. The engineering subsystem group, this is described by 14 average use cases and 8 simple use cases. I am all talking only about use cases here. So we have 14 average, 16 complex and 8 simple use cases. The last one, infrastructure subsystem group, it has 10 simple use cases. So either you combine this, make it 18, or you can do it separately also. Good idea is to combine them, 10 and 8, 18. We have done the use case part. Now let us come to the actor part. Now we assume that we have 8 simple actors. So now this box is for actors. 8 simple actors. We have 12 average actors and 4 complex actors. Okay. Now how do we compute what will be the final value of UUCW and UAW? Let us see. We multiply with the weighting factor or weight factor and then we add. 8 into 1, 12 into 2 and 4 into 3. Then we add. Okay. So first one value will be UUCW, second value will be UAW. You'll just see how we do it. Let me show it here. You just see the final equation. Now, as I said, how much values were there? We just discussed. So the complex were 16 use cases. 16 use cases were there. So 15 is already the weight. So multiply. Now, we have to write at NCUC 16 in place of NAUC, that is the average complexity use cases is 14. And as I said, we have already 18. 8 plus 10, 18. You can use like that. Or you can make it 18, or you can use 8 use cases and then 10 use cases. Ultimately, you have to multiply it with 5. So 5 into 18 will be this value. And from here and here it will come. 10 into 14, you write here. 15 into 16, you write here. So we have already done the computation. 16 into 15 plus 14 into 10 plus 18 into 5. Or you can do 8 into 5 plus 10 into 5. Finally, a 470 will come. UUCW is 470. 470. I'm not doing the whole calculation. UAW, how to find out the UAW? See, UUCW already found out and adjusted use case weight. Now we are going to the actors. Okay, how many actors were there? 8 simple actors, 12 average actors and 2 complex actors. Now multiply them. 8 into 1 is 8, 12 into 2 is 24, 3 into 3 is 9. Just add them, you'll get 44. We already computed it, so I'm just writing it. 44. Now coming to TCF and ECF. I'm just writing the numbers also. Now TCF we have to find out. TCF, these are T1 to T13. These are what? These are technical factor. Now, T1 to T13. These are the names. Now the weight is already fixed. This is already known. You are not going to change it. But you have to, depending upon your project, you have to give a value from 0 to 5 in this column. For example, randomly I'm giving some value. You have to give a value from 0 to 5. It has only to be between 0 to 5. So 5, 2, 3, 2, 1. Like depending upon your project, you have to spend time on this. Now multiply this. 2 into 1, 2, 1 into 2, 2. Like this, every 2 values you have to multiply. And finally, what you get this in this column, you have to add. Add all of these in this column. So you will get T factor. Total technical factor. This is not TCF. You get a T factor. For TCF, there is an expression. What is the expression? 0.6 plus 0.01 into T factor. So you have given the value here from 0 to 5. You got the last column. You added the last column. That is going to be T factor. And put it here in this formula. When you put this, you will put value in this formula. You will get a TCF. I'll just tell you what the TCF value will be. Before that, let me go to ECF. ECF is for environmental factor. So these are F1 to F8. This description is like you want to value something for motivation. So you have to give value from 0 to 5. These weights which are given from 1.5 to minus 1.0, these are fixed. These are fixed. You don't change it. Now you have to give the rated value from 0 to 5. For example, motivation is there. You get a 3 value. You multiply 3 into 1. You will get 3 in the last column. Same way. So 1.5 into 1. What do you get? 1.5 here in the last column. 0.5 into 0. You get a 0. So you have to do for each of them. I hope you will be able to do and just write every value and add them. That is going to be a E factor. I'm not saying it is ECF. It is E factor. Again, we have an expression for ECF. ECF is 1.4 plus minus 0.03 into E factor. Now put this E factor here. So I'm just saying that we have already done the computation. You have given the value, rated value. Let us say that the TCF comes to be 1.04. ECF comes to be 0.96. Okay. You got the T factor, put it here, you will get the TCF. You got the E factor, put it here, you will get the ECF. You may give any number from 0 to 5 in all the columns I said. So the values may change. I've given these values, so I get 1.04 and 0.96. So now what all values you have? See, UUCW is 470, UAW is 44, TCF is 1.04 and ECF is 0.96. Okay. Now, after evaluation of technology and environment, we have just seen we have got the TCF and ECF, and now we are ready for the final expression. 470, 44, 1.04 and 0.96. 513 will come. Now 513 is our final value, the use case points. Now what is the significance of this 513? What to do with this 513? This is whole of the flow chart I have shown. So for example, using the past project data, the development group has produced 85 line of code per UCP. That is, for one UCP, each UCP there will be 85 line of codes will be written. So we have 513 here, and the overall size of the project we just saw is what will be there. 85 is LOC per UCP multiplied with 513 UCP. Multiply 513, you got the use case points multiplied with the 85 LOC per UCP. You will get 43,605. Let us take it as 43,600. Now, similar computation can be made for applied effort or project duration. Say we have 620 LOC per month as the average productivity for system of this type, and there is a labor rate of 8,000 per month. This is also given to us with our past experience and past projects cost and the present cost. So what will be the cost per line of code? What will come? See, we already know, we already done that. So we have this 8,000 is the cost. Take this, divide it with the 620 LOC per month. So you get 13. So this will be the cost of per line of code. Now, based on the user estimate, use case estimate and the historical productivity data, the total projected cost will be what? 13 is the cost per line of code, and we have 43,600 lines. So multiply this 13 into 43600. What do you get? 566,800. Now we have the historical data also, so you can just combine them and average them. So you will get 552,000. Even if you want to keep 566,800, it's good. It's similar to that value only. The difference is not that much. Now effort also you have to find out. The estimated effort will be what? See, there are values we have already found out. So we find out the person month. So you have the line of code 43600. You have 620 LOC per month. Divide them. What do you get? 70 person month. This is the use of UCP. How do you find out the estimation, the cost, effort and duration of a project? Reconciling estimates. Sometimes we use the function point methods. Sometimes we use the use case or the process or LOC method. But the estimates, sometimes when we combine them, the estimates are sometimes poor. So these widely divergent estimates can have one of the two causes. The scope of the project is not adequately understood or has been misinterpreted by the planner. This can happen. Or the productivity data which is used for problem-based estimation technique is inappropriate for the application, obsolete, or has been misapplied. So sometimes you face this. Empirical estimation models. The structure of estimation models. Now there are certain models which have been developed with respect to past projects or the experience from the past data, and there is an equation. We have certain numbers here which are empirically being found, derived, and these are the estimated expression for time. You can compute the time, you can compute the or determine or estimate the effort and also the dollar, that is the amount, the cost of the project. So here you see a regression regression analysis is a problem of curve fitting. So you have certain points, certain data which is already there, and then mathematically with respect to graph analysis, we try to fit a curve. Normally we will like to fit a line, and this line is a regression line, and this is the regression analysis. So now when we know that certain expression is found, now you can just put the value and find out for every x what is y. Similarly, for every function point or LOC, what will be the estimation values. So this is the expression. The overall structure of these kind of models developed historically from then when software started, development started till now. It is E equals A plus B into EV to the power C. A, B and C, these are empirically derived constants. So that means if you just take a line, y equals mx plus c. This is the standard line equation. Now y is dependent on x. X is the size here what we are talking about. M and C are constant. So when M and C are constant, just try to make an analogy between this line and this expression of estimate model. So here we have A, B, C are empirically derived. That means with respect to last experiences, these A, B, C are being derived. What is the E here? E is the effort in person month. The effort per means how many people you have to take, what effort you have to put to complete the project. So E is always in person month. And then we have E sub V. This is the estimation variable. A, B, C are constant. So EV is analogous to X here for the line. So EV is, can you put the LOC? Yes. FP? Yes. Line of code, the function point. Even you can use the use case points and the processes. But most of the time we take this line of codes and function point. So these models have a project adjustment component for E also that we'll see. And these are adjusted by another project characteristics. What are these project characteristics? The problem complexity, what is the experience of the staff, and what is the development environment like. And these empirically derived models, this must be calibrated for your local needs also, because every project, everywhere the work is done is different from another. So this is how the basic structure of estimation is formed. The COCOMO model. Now what is this COCO? What for this COCO model is used? For any project, mainly the software projects we are talking. So it is always before the project management can even start or project planning can start. We need to know how much cost this project is going to take. What is the time it will take to complete, and how many people, that is the effort that is to be employed. So Barry Boehm, he introduced software estimation models bearing the name COCOMO. And this COCOMO has come from constructive. First CO has come from constructive. Second CO has come from cost. And MO has come from model, constructive cost model. Originally, when this COCOMO model came, 1981 it came, and it became a hit. It was widely used, and then because of changes in the software technology environment, it has evolved into more comprehensive estimation model, COCOMO 2. So COCOMO 2 is a hierarchy of estimation model addressing different stages of the software process. Whether you take waterfall, spiral, these are SDLCs I am talking about. So COCOMO 2 models requires input as what? Sizing information, and that is the size, line of codes or function points, etc. So these are sizing option. It can be the object points, it can be the function points, function point analysis we have already seen, and the line of source code. Now we also call it as the DSI, that is delivered source instruction. COCOMO 2 is 1995 extension to the earlier Kokomo 9081 model that incorporates various other things like the object-oriented paradigm, orientation, modern life cycle models, the rapid prototyping which has come, the agile kind of development has taken place, the rapid prototyping, the different languages which has come up, 4th generation languages, and the component of the shelf or the Scotch software. So there are 3 forms of the Kokomo. There are 3 forms because, the project can be different. It can be basic, it can be average, it can be complex. So these 3 forms of Kokomo, first is the basic Kokomo, which is the macro estimation actually, which gives an initial rough estimate of man months. Man months is the effort and the development time. How many people, how many effort with respect to and development time. So then we come to the intermediate Kokomo. First, the project is basic, it is small, and if we go up to the medium sized project, intermediate Kokomo, which gives us more detailed estimate of it. Finally, we have detailed Kokomo, which is the micro estimation, which gives a more detailed estimate, especially for the large projects, the complex projects. Basic Kokomo model. So the basic Kokomo model gives us an appropriate estimate of the project parameters. Kokomo is the constructive cost model. So what is the estimation? That is the time span of the project, how much effort we are going to put or need to be put, and finally the dollar, that is the cost of the project. And then the basic Kokomo estimation model, there is an expression, and this expression has empirically been suggested. So effort is A1 plus kilo line of code, KLOC, to the power A2. This will come in person month. Always remember, the unit of effort is person month. 1 person, 1 month, how much work. And once you found the effort, then we can estimate the time. The time expression is, time to development is B1 into effort to the power of B2. And this will come in months. Please remember, in months. Now this KLOC is the estimated size of the software product expressed in kilo lines of code. If it is 3000, you have to divide it by 1000. Okay, kilo line of code. And now we also call it as KDSI, that is kilo delivered source instructions. So these are almost same thing, just a bit difference. A1, A2, B1, B2, these are constant for different category of software products. There are 3 categories. One is organic, the second one is semi-detached, the third one is embedded. So the question will give you, or the project will tell you what kind of project it is. And depending upon that, you are going to use the A1, A2, B1, B2 value. T development is expressed in months. This is the time to develop. And finally the effort, the total effort required to develop the software product. And this is expressed in PM or person month. Let us take an example. Now assume that the size of the organic type, so the project type or type is organic type, has been estimated 32,000 line of code. Average salary for engineers is 15,000 per month. We have to determine the effort and the time. So how do we find it? We will use the, first of all, this is the table you need to remember. Organic type is there. If it is organic type, the effort and time expression is already given. This 2.4 and 1.05 are A1, A2, and 2.5 and 0.38 are B1, B2. Now effort will be, effort expression is, let me write it again, A1 plus kilo line of code. Sometimes you are given the function points, so you can use function points also. So KLOC, kilo line of code to the power A2. What is A1? 2.4 for organic. A2 for organic is a 1.05. And what is the kilo line of code? To the A1, A2 constant. 32,000 is the line of code. But this is kilo line of code. So 32,000 you have to divide by 1000. So you get 32. 32 KLOC. Now when you put these value into this expression, 2.4 plus 32 to the power 1.05, you will get 91 person month. This is the effort, okay, per month. Then time to development. So we have an expression B1 into effort to the power of B2. Remember, effort we just found out, we computed, to the power B2. This will come in months, not in year, months. Now in order to get the time development, just put effort here. Now you see for organic what is in the table. What is B1 and B2? B1 is 2.5, B2 is 0.38. These are fixed values for the basic COCOMO. When you compute this, you're going to get 14 months. That is 1 year, 2 months. What will be the cost required to develop the product? See, 14 months are there. Every month you have to pay 15,000. So what will be there? 14 into 15,000. So that will be the cost required to develop the product is 2,10,000. Intermediate COCOMO model. Now in this intermediate COCOMO model, the basic core of COCOMO remains the same. Only because of the change in technology and other aspects which has come. One more aspect, which is EAF. This is the adjustment factor that has been added here or multiplied here. Okay, so the same basic equation for the COCOMO basic model is used, but 15 cost drivers, these are rated on a scale of very low to very high. See, these are 15 parameters and very low to very high to calculate the specific effort multiplier, and each of them returns an adjustment factor which multiplied it will yield the total effort adjustment factor. For example, you say that my software require a lot of reliability, strong reliability. So you are going to take, say, very high reliability. You are going to take this one, required software reliability. This is the product attribute, cost driver. So if you want very high reliability for your project, you will take the value as 1.40 in EAF. If there are multiple values you have to take in your project, if it is required, then you will take all the values and multiply it to get the EAF. It is simply the multiplication of these value being taken. In addition to this EAF, the model parameter A, this has slightly changed from the basic COCOMO model. Basic model, the values has been changed, but the parameter B is similar. So let me just show you again, because I have to show you the equation. This was the basic COCOMO equation, okay, for effort and time development. This one A1, A2, B1, B2. But in the second part of basic COCOMO, that is the second version, which is the intermediate, only A and B are there. A remains same, A is slightly changed, B remains the same. Okay, now the question is database system for an office automation project. The project is simply given as organic. A value is already provided to you as 3.2. B already provided 1.05. C is also there, 0.38. Now 4 modules to be implemented. What are these modules? Data entry 0.6 kilo data. This the delivered software instructions we are talking about. Data update, query, report generator, all these are there. But the system size is also given 3. Okay. Now what you are going to do here is, see, the cost drivers, the level, and EAF is already given. If it is not given, you have to use the table. That if it is complexity is required, to high level storage, to high level experience, to low level, and programming capabilities or programmer capabilities to low level, this EAF has to be used. These are value. I showed you the table. So these are the value, and this will be corresponding to or will be coordinated with the EAF, adjustment factor, effort adjustment factor. Okay. Now this is the expression of the intermediate COCOMO. E equals A KLOC to the power B multiplied by the EAF. This is effort adjustment factor. So what are the values of A and B? The value of A is slightly changed. The value of B remains the same. Okay. So since this project is organic, the time is like this. This time value is 2.5, which is the V1, and power is V2, which is different values. Okay. Sometimes in various books you will see this MMKORR. Don't worry, this is nothing but the effort. Sometimes you will see LOC, line of code. Somewhere you will see KDSI, that is the delivered software instructions. But the basic idea remains the same. Now these are the EAFs. These are the EAFs value. What you have to do, you just take them, multiply them together. Multiply all of them, then you use the expression. So this is EAF already used. Now you have to put A here. We are just multiplying all of these, and this will come to 1.61 when we multiply all of this. 3.2 is already given in the question, and in the table also you see A is 3.2 for organic. What is the kilo line of code? See, the system size is 3 KDSI. So whether KDSI or KLOC, you are going to put it here, 3. And then what is the B value, the power B value for organic? It's given in the question also. You can use it here also, 1.05. So in organic, A will be 3.2, B will be 1.05. Put this in the expression here. What do you get? 3 raised to the power 1.05 will give you the value of 3.17. So you have this whole value is 1.61. 3.2 is already there. 3 raised to the power 1.05 is 3.17. And when you multiply all of these, you will get 16.33 MMKORR. Sometimes it is called as effort. Now let us come to the time of development. Now this is organic and you already have the table. So this is 2.5 E, effort raised to the power 0.38. Effort we just found out to be 16.33. So you have 2.5 multiplied by 16.33 effort raised to the power 0.38. And when you put it, you will get 7.23. And since it comes in months, so it is just over 7 months. Just over 7 months, or 7 months and a quarter of a month. Now how many people should be hired? And for that, this is very simple division. You divide the effort and the divisor will be time of development. So 16.33 divided by 7.23, which is the effort divided by the time of development, and that is going to give you the number of team members. So when you do 16.33 divided by 7.23, you will get 2.26. So it has to be greater than 2 team members, so around 3 members you will need. The software equation. Now this software equation, if you see here, there are various variables. So this is a multivariable, a dynamic model. And what it is assuming? It is assuming a specific distribution of effort over the life of the software development project. And from where it has come? The software equation. This has been derived from productivity data collected for over 4,000 contemporary projects. Okay, from there it is derived. The equation is like this. E is effort. It will be in person month and person years. LOC is line of code. Please understand, it is not KLOC. Most of the expressions we have seen earlier are in KLOC. B is the special skills factor. And then we have the P here. P stands for the productivity factor. We'll take the example. And this T is the project duration. This can be in months or years. Okay. Normally we take it in years. So let me tell you again, in this software equation, effort will be in person month, person years. The time, which is project duration, in months or years. And this B is the special skills factor. This P is the productivity parameter. Now what this productivity parameter says, this says about what is the overall process maturity, say CMMI, which level you are, and the management practices in your organization, the extent to which good software engineering practices are employed, are used, what is the level of programming languages you are employing, and the state of the software environment. the skills and the experience of the software team, and finally the complexity of the application or the system or the software you are working upon. So this comes under P. So let us say we have already known E, B, P, T now. So this is the productivity factor, P. This, if you have a real-time embedded software, so P value for this will be 2000. Real-time, that means you want response with bounded time, and the embedded software like your micro oven or your washing machine, you have embedded software. You will take P as 2000. P is 10,000 for any telecommunication, data communication, this software and this system software like drivers. P will be 28,000 for, say, business system application. That is, a lot of things are involved here. The productivity parameter P, this is derived not only from the past experience, that is the historical data, but also the local conditions for the past development. So we'll take an example where P will be different, and this is how this P will be given. The software equation has two independent parameters. What are these? See, B and P are prescribed value. We know it. So the line of code will change for a product and the project duration. So line of code and project duration, that is the time, that is going to be your independent parameters. So let us say we have a function y equals fx. Now this x is the independent value, independent variable, and y is the dependent variable. So E is the dependent variable on the LOC and the time. So Putnam and Myers, they simplified this estimation process and with certain restriction, and they suggested equation derived from the software equation, which is this one. So what will be this one? The time, the minimum development time is defined like this: 8.14 into LOC by P to the power 0.43. P is the productivity factor, and this will be for when the minimum time is greater than 6 months. Then you use it. And what about the effort? The effort will be 180 into B. B is the special skills factor. This also has a specific value for specific projects in person month. When the effort is higher than 20 person month. T, as I said, you will use it here in years. Let us take an example here. You have to make a software package for a computer aided design application, CAD application, for the mechanical components. Now you made the scope, you devised all the functions, and finally you are ready for the estimation. And let me tell you all we have done in the function point analysis, use case analysis. So we have the values. So I'm just putting the values. Say for this particular project, this is recommended value. P is 12,000. Assume it to be a scientific software. So P will be 12,000 for this particular problem or this software to be made. The line of code, as we already estimated earlier also, and we can give a number. So it will be 33,200. The B value is specific for this CAD software. There are other softwares, so there will be specific value, B value for, that is this special skill factor, because this CAD development needs a specialized skill factor from the team and the expertise they require. So we have 0.28 as B. LOC is 33,200. Now let us find out the time and the effort. So just put LOC as 33,200 here, and P you are going to put 12,000, and then you will get the time, which is the minimum development time. And the result will be like this: 8.14 into 33,200 divided by 12,000 raised to the power 0.43, and that is going to give you 12.6 calendar month. Now this is the calendar month, so you have to convert it into years. 12.6 month is equivalent to around 1.05 in years. So we are going to find out now the effort. So we have 12.6 as I just suggested. You can just convert it into years. And then you can apply 180 b t raised power 3, all 3 multiplied. So 12.6 is around 1.05. So just put it here in place of time. 180, b is, as I said, 0.28. So you get 58 person month. This is how you compute value from the software equation. Estimation for object-oriented projects. Now, when we have the projects where we are using the object-oriented paradigm, we have classes, object, inheritance, all these encapsulation, polymorphism. So it is worthwhile to supplement or to add the conventional software cost estimation method. We have already used the FP method, function point, the use case point, COCOMO. There are so many methods we have discussed. And we can combine this with a technique designed explicitly for the OO, object-oriented software. So Lawrence and Kids, they suggest a certain approach how to do this, how to estimate the object-oriented project time, effort, and the duration and the person month, of course, the dollars. So first, using the requirement model, first you have to develop the estimate using the effort decomposition, FP analysis, etc. Then you will use the requirement model. Then you'll see how many use cases can be formed. And then we have to determine the count of these use cases. This requirement model, as we have already found out the use cases, we have to determine the number of key analysis classes. There are certain key classes, there are certain supporting classes. So say you have certain number of key classes. Now you have to categorize these key classes in terms of whether it is no GUI without any graphical user interface, or whether it will be text-based user interface, whether it will have GUI, whether it will have complex GUI. So this analysis classes will have support classes. How to get the support classes? You have to multiply the number of key classes in the categorized way from no GUI to complex GUI and multiply it with a multiplier. Okay. Say if you have, say, analysis classes, which is GUI based, how many classes are there? Just assume that there is a number. So in order to get the support classes, you have to multiply 2.50 with that number of analysis classes. So if you have 2 key classes, you have to multiply it with 2.5. Which number? This is the multiplier. Same you have to do with other analysis classes defined into category and then multiplied by the multiplier which is given in this table. And that is how you get the support classes. So now you have the key classes, you have the support classes. Now you know all the numbers of the classes, and classes are the basic say size estimation for the estimation of the object oriented projects. So for each of these analysis classes, you have to multiply. What I am showing right now is like this. Say n numbers of analysis classes, multiply if it is no GUI, multiply it with 2, with text-based user interface 2.25 likewise. Okay. Now when the classes are being known, you have to multiply it with that is the total number of classes had to be multiplied by the average number of work units per class. Now to get this. Now Lawrence and Kidd, they have already provided an idea. They say 15 to 20 person days per class. So multiply this class with either any number between 15 to 20 which you see is better for your particular project. And then you can cross-check the class-based estimate by multiplying the average number of work units per use case. So this is how a very easy method to find out the estimation of object-oriented projects, basically based on the number of finding out the number of classes. Estimation for agile development. Now agile, everything is very fast. The time is less. And you have to just, roll it and give it the product, multiple increment, multiple times. So because the requirements of this agile project are defined by user scenarios, you can call it as user stories in some of the agile. Normally we don't make the SRS like we do in the waterfall or spiral, etc. So you have to actually go for user stories, user scenario. So in extreme programming, we call it as user stories. In Scrum, we call backlog, etc. So this is the extreme programming stories. You just assume it to be user scenarios. And this, because the requirement is so fast, so we can develop an estimation approach which has to be informal. Agile is a kind of informal approach only, reasonably disciplined and meaningful, and finally, with the context of the project planning, for each software increment, we can do this informal, reasonable, disciplined, and meaningful way of estimation approach. Now, how do we do this? First, let me tell you, there are multiple different agile estimation techniques, and they have been developed: planning poker, t-shirt sizes, dot voting, the bucket system, large and uncertain small, affinity mapping, ordering method. There are different methods. So agile project estimation uses decomposition approach. First of all, each user scenario or user stories is considered separately for estimation purposes. Now the scenario is then decomposed into software engineering task. The scenario will be divided into what kind of software engineering task we are going to apply here. Each task has to be estimated separately. That is, estimation can be done based on the historical data. You can also use the empirical model. We have already seen the different kind of empirical software equation, COCOMO, etc. Or experience also. Okay. Now, once this is done, you can also choose an alternative. Volume of the scenario. Now, this is quite, we have seen in earlier discussions, estimated in terms of LOC and FP, function point sizing parameters. You can use that also. Or the volume oriented measures like the use case count. This also can be used. Now, the estimates for each task, we have done already that thing. They are added, they are summed to create an estimate for the scenario. Or if you are using volume estimate for the scenario is translated into effort using the historical data. The effort estimate for all the scenarios are added in order to get the final effort estimate for the increment. So this is how estimation for agile development is done. Because the project duration is around 3 to 6 weeks, this approach serves two purposes. To be very certain that the number of scenarios to be included in the increment, that is next increment, conforms to the available resources. Along this, to establish a basis for allocating the effort as the increment is developed. Okay. So this is how we do the estimation of agile development. There are multiple methods. Estimation of web application or web app projects. Now, this web app project adopt the agile process model. So we can have a modified function point measure, line of code with agile project estimation. This can be used to develop an estimate for the web app. Now, Rolson, he suggests a certain approach when adapting function points for the web app estimation. That is, when we use the function point, there are 5 input parameters. So what are the inputs here? Each input screen or form, we have already seen about function point. So I'm just giving you what are the parameters you have to use. Each input screen or form, each maintenance screen will be input. If you are using multiple tabs on your software, finance software, that is for a tab, notebook, metaphor, anywhere, each tab will be the input. Outputs are each static web page, each dynamic web page. For example, you have ASP, ISAPI, or the DHTML script. Each report, whether it is web-based or it can be administrative in nature, that will be output. What are the tables? That will be each table, a logical table in the database. Along with this, if you are using XML to store data in a file, each XML object will also serve as the table. And interfaces are logical files, for example, unique record format. into our out of the system boundaries. The queries, what are the queries? These queries can be each externally published or use a message oriented interface like DCOM and COM external interface. So if these inputs are known to you, you can easily use the function point for the web app projects. The make and buy decision. In various fields, even in the software application areas, it is more cost effective to acquire than to develop the software. Rather than developing, why not to buy it, acquire it, a part or full? So manager, they generally face make and buy decision when with number of acquisition option how to acquire certain things. First of all, software may be purchased. It can be even licensed off the shelf. Just go and buy. This is the first method. The way you buy from the Walmart. The full experience or partial experience software components. This may be acquired, then modified, and now it can be integrated to meet the specific special need of your particular application. Now, software can be even custom built by any outside contractor to meet the purchaser's specifications. So these are the acquisition options. Now, this make or buy decision is made based on certain condition. What are these conditions? Will the delivery date of the software product be sooner than that for internally developed software? That is, if 1 year you take the software to be delivered, and if you acquire it or buy it, it's much lesser time duration. It's better. Or you give the software to someone to be made, so that he will make the time will be less. Will the cost of acquisition plus the cost of customization be less than the cost of developing the software internally? So making your software will cost more, or buying it or acquiring it cost more. This is the buy and make decision which we have to make. And will the cost of the outside support, for example, the maintenance contract, be less than the cost of internal support? That is, because once you deliver the software, there is a huge work of maintenance also. That is also costing. So here you see a decision tree for a software-based system. Let us say the software system is called as X. What an organization can do? The first thing it can do, it can build this software X from zero, from scratch. Or these organization can reuse the existing partial experience components to construct this software or the system. This can be done building from the scratch or reusing the partial experience component. They're already there. We use them, put some more code and make a software. Or you can buy an available software product and then we can just change it, modify it with respect to our local needs. This is the third thing we can do. Or the organization can do one more thing. It can contract the software development to an outside vendor or a company. These are multiple options. So these are the different options. Now let us say all these numbers you have to divide, right? If you say that an organization has to build a software from the scratch and the organization has decided, the managers have decided 70% probability is that the job will be difficult. That means 30% probability that the job will be simple. And this has to be done for all the options: build, reuse, buy, contract. So when you are building, I'm just suggesting that the difficulty or the complexity factor is 70%, that is 0.70, and simple is 0.30. So the project planner now project the cost, that if you go with the difficult way, the effort will be $450K. That is $450,000. A simple development effort will be $380K. So the expected value of the cost, how do we compute it? There is this expression. Let me tell you how we will actually compute it. Okay. Now we have a X system. Now we would like to build it from the scratch. Now the organization has already known that there is 70% probability that the difficulty will be there. 30% probability it will be smooth, simple. And the cost being estimated on these two, first one is 380K, that is $380,000. I'm just saying 380K. Okay. For the difficult part, if it is known that this will be 450K. What is the expected cost for building the product from the scratch? What you have to do is you have to multiply 0.3 with the 380K, and then you have to multiply 0.70 with 450K and then add them. 0.70 into 450K and just add them, and the value you get is 429K. Now this has to be done for reuse, buy and contract. This I already did for this one. This has to be done for all these, and the lowest cost has to be the final one. So let us do the other one also. Expected cost for the projected cost for reuse, purchase and contract under a variety of circumstances. For example, you have a reuse. Here can be major changes, minor changes. In major changes, you can have simple and complex. So we have multiple branches here. So first you have to take the 0.40 into 275K. Then you have to do 0.20 into 310K and 0.80 into 490. Then you have to add them and then multiply this with 0.60 and then add with 0.40 into 275. I hope you got the idea. Okay. So it is given here also. 0.20, 0.80. Whenever we are doing, we have to multiply by 0.6. For the expected cost for buy, 0.70 into 210 and 0.30 into 400. You get 267. And for the contract, 0.60 into 350K plus 0.40 into 500, you get 410K. So one is 429, 382, 267, 410. What is the lowest one? So the organization will decide, let us buy it. So based on the probability and the projected way, the lowest expected cost is the buy option. Now all this is said and done. The availability, the experience of the developer or the vendor or the contractor, the conformance to the requirement being formed, the local politics, and the likelihood of the change of criteria other than the cost, this also may affect the ultimate decision to build, to reuse, to buy, or to contract. Outsourcing. Outsourcing is giving your task or work to some other. Subletting, contracting, giving, renting, like this. So the question where all it starts, is there a way that we can get the software and systems we need at a lower price? Yes, it is possible. Rather than doing, say, for $10, can you make it with $5? Is it possible? The answer is yes. Outsourcing is the solution. So outsourcing is a software engineering activities. These are contracted, given to a third party who does the work at lower cost, and hopefully we can just hope that he or she, that is the company people, they give you higher quality. And now when you give the contract, the software work conducted in your company called C1 will be merely contract management activity for the work which is done actually at C2. So you are giving a contract. Merely you are doing the contract management activity. Now the decision to outsource can be two ways. It can be strategic, it can be tactical also. So the strategic level, what does it mean? The business manager considers whether a significant portion of all software work can be contracted to others. The tactical level, the project manager determines whether part or all of the project can be best accomplished by subcontracting the software work. So these are the two level understanding has to be made. What are the benefit pros? The cost saving, you don't need to put any computer, infrastructure, you don't need to hire people, less people. The cost saving by reducing the number of software people and the facilities, the infrastructure. The cons is company loses some control over the software that it needs. So you are giving control to somebody else. Sometimes you don't want to do that if it is, very strategic kind of thing. Actually, company runs the risk of putting the fate of its competitiveness to a third party. If there is a competitor, say company 3, you are giving it to company 2, maybe Anything can happen. So, you need to be very sure of that. Okay, this is all about this discussion. Thank you so much. Take care of yourself.